Hello. All right. Okay, finally, I did a full 45-minute live stream and I was wondering why there was no students interacting, even though there was plenty of people that were waiting or viewing, and it was entirely my fault. So, I have learned my lesson and I will make sure I hit that go live button. So thank you for being here. As I troubleshoot, sometimes I am rusty with my live streams at the beginning of the semester, so I do apologize. So here we are with our first lab. I I'm hopeful that you are able to see everything that I post along the way. I am going to just give a quick overview and let you know that I do make these live streams available. The link should be available at any time, and I will a link on our Canvas page in some way, shape, or form when I have a live stream, a channel link, or a way to access the video. So you can go back at any point if there's something while you are maybe working later in the semester and you'd like to come back to. So with that, I also want to let you know that I do have the live chat enabled. So if you would like to comment on anything, if you have any questions along the way, please feel welcome to comment on there. Same if you can't hear me. If you would like me to switch microphones, I am also happy to do that. Just let me know how I can best support you as you are tuning into these videos. So there might not always be a live stream, but I generally do live streams when I feel students could use a little more guidance, particularly say they are new to something like maps. Maps aren't necessarily a skill most students come in knowing a whole lot about. And so with that, I'm going to kind of do a little walkthrough to hopefully help you get started or to build your confidence as you have gotten started. So let me start by going ahead and sharing with you what I see in my what's called my student view for my Canvas page for this class. And hopefully you can still hear me. I got some weird little error thing that it wanted me to share my audio. So anyways, if you can still hear me, that's amazing. Please make sure that you're letting me know that in the chat if you can't hear me, because it would be a bummer to do a whole nother live stream again and have students not be able to hear me. So for the live stream, the way that it generally works is I'm going to give you a quick overview, maybe touch on a few points that students historically have struggled with or need a little more guidance with to get started. I hope to keep it about 15 to 30 minutes. Realistically, it could be a 45-minute long video, but I'll do my best to go through things quite quickly. And then if you still need some clarification, please go ahead and pop that in the chat for me so I know. So this is what I see on my Canvas homepage in my student view. If you're here, you found this link somewhere along the way, whether it was my original or my goof, but my redo, it was the same video link. And each week I will do my best on Mondays. I may try and do it on Sundays, update our homepage, and I'll let you know the outcomes for the week, your assignments. I try my best to link the assignment here, but I may or may not always have that down pat. So if that's the case, and you're not sure how to access our lab activity, the lab activities can be accessed here in your weekly to-do, or you can go to the calendar and you can find our course, and you'll find this is the activity. You can also go to our modules page, and I strongly recommend being familiar with the modules page so you can always go back and see information. And here is our topographic maps assignment. So this will be the theme for each topical assignment, so whatever the topic is. So I'm going to click that because this is where you get your questions. Now, if you've found these questions, amazing. If you haven't, that is where they will always be because they are locked until Tuesday mornings. And I have opened this up for you, but I also want to make sure that if you're doing this, you have your work packet. You'll notice in the map activity, there is no place to record answers, and that is on purpose because I want you to be recording them here on your work packet. If you scroll through the packet, you'll see there are spots for calculations or spots for things like drawing, annotating, and that is intentional. Now, I release these Friday mornings at 6 a.m., I believe. So that's Friday, Saturday, Sunday, Monday, Tuesday, Wednesday if needed. So multiple days for students to access and to print before the activity is due. It needs to be completed on a handwritten paper lab, and you're honestly going to get a lot more out of it when you do the actual handwriting portion of it and physically do your skills that way. So now that you have those materials, the other thing we need to make sure is that I've included supporting resources here, like the Santa Barbara Quadrangle. Click that and it'll open this map. Now, if you don't click it and download it, you can click it and it will open inline. These maps are large files. You can zoom in on this document here on this file, but it is a big file, so it isn't going to be really high clarity if you zoom in, as opposed to actually looking at the downloaded file. You can zoom in a whole lot, and it might lag a little bit right now because it's such a big file, but you'll see that the more you zoom in for this map, the clearer it is. You can't get this resolution with the one inline, but you can still answer the questions. It'll just be a little bit harder to see. Students have been downloading this file for over 5 years and have had no issues with it. So if you feel comfortable doing that, I recommend downloading the maps. Okay, so now that you have all of the materials, I'm going to take a quick pause and make sure nothing's popped up in the chat. It seems like I'm still live. You can still hear me, and I'll go from there. So for our activity, you are going to need to make sure you're referencing that quadrangle. I have that map here. You've accessed it. And you're going to answer some questions. Now, the only places for this activity you're not going to reference that Santa Barbara quadrangle includes more map reading practice because there is a map attached, and part 2. The rest of that this activity, you're going to reference the Santa Barbara quadrangle and become familiar with it. And why are we focusing on maps? Well, we're going to use maps in, I think, almost every single lab activity, except for maybe next week, for the rest of the semester. The amount of information a map can convey is so important for us in environmental applications. It allows us to view spatially, so the distribution of resources. It allows us to understand how the topography or the surface expression can be prone or not prone to hazards. And so we're going to be really familiar with them. Now, I'm not looking for expert level skills this first week. You will build on them time and time again, and you will get more and more comfortable with them. But I know it's a lot at first. It's a lot if you've never really looked at maps. It's a lot if you've never really thought about surface expression or elevation. Why are there mountains? Why are there hills? And how that can be related to environmental practices. So this can seem a little daunting at first, and I want to encourage you that things will be unfamiliar. You're going to build skills, and it's going to get more familiar throughout the semester. It's really important that you spend the time now to get used to that kind of information so that you feel confident moving forward to continue to build on them. We're going to look at maps for groundwater, for streams, for um, rock and mineral resources, for waste management, for think maybe even coasts and coastal expressions. So lots and lots of different applications throughout the semester. So now that I've tried to sell you on it, the map scales and distances, the miscellaneous margin information. A lot of these questions can be answered by going to the map and quite literally looking around the edges. So I've zoomed in quite a bit. I'm going to zoom back out. Now, this map here has a lot of information on it on the margins, including most notably the bottom. Again, it's a big file, so it's a little lagging on my side. What I want you to do is take a moment and make sure you're familiar with where there is information on this map. The first questions of your activity ask you what the scale of this map is, and specifically asking you what the RF scale is of the map. The RF scale is what's known as a ratio scale or a representative fraction, but most of our maps don't have it in fraction form, so I just call it an RF. It means 1 to something, and that scale is here on the map. Nearly every map I give you this semester will have a scale on it. It's your job to find that scale and to understand what it means in terms of the magnitude of the information that you're viewing. So this is Santa Barbara and a little bit of the surrounding area, including the San Ynez Mountains in the distance. And so it covers a fair amount of space. This scale tells us 1 to 24,000. The one side, the left side of that scale, meaning one of some unit is on the map is equivalent to 24,000 of that same unit on the ground. We will only ever measure in inches or centimeters on our maps, and so we're going to assume the left side can only ever mean 1 inch or 1 centimeter is equivalent to 24,000 inches or 24,000 centimeters. So we can convert the scale, and that's part of your job for the second question, is to convert it into a format that reads 1 inch is equal to so many miles on this map. Now, as a hint, your answer for that should be less than 1. It's actually a decimal, it's less than half a mile. But how do we get there? Well, we imagine that this is a ratio, meaning as long as the units are the same for both sides, it is valid. But I ask you to give it to me in a format where the units are different on both sides. I ask you to give me what 1 inch is on the map, that left side here, is equivalent to in so many miles. The way we get there is by starting by making both sides the same unit. So I can convert this RF scale by saying 1 to 24,000 is actually 1 inch on the map is equal to 24,000 inches in real life on the ground. So whatever 1 inch would be on that map, it would have to be 24,000 inches on the ground. And then we can convert 24,000 inches into miles using a conversion scale I've provided for you. So that's where you're going to work towards for question 2. And once you have that understanding, you can determine, well, if 1 inch is so many miles, 2 inches must be so many miles, and 3 inches, and it becomes a multiplication problem. So as you're going through, that should be hopefully clarifying. And again, remember, you're practicing, you'll get some feedback when I grade and to help guide you in the correct direction as needed. But if you also need more guidance, please feel free to join my student help hours. You can sign up and make your own appointments at any time. Okay. So the next thing I wanted to point out is that I am still welcoming questions. If you have any questions, please drop them in that chat so I can answer them in real time. Otherwise, I'm just going to help point out a couple of features on the map so to help guide you for these. So question 7 says to ignore any bathymetric or ocean contours. And that's these blue contours here. We're going to ignore them. They're important, but not for what we're doing to calculate the relief. So you can ignore them for this map. Question 8 asks you to find the top of the stadium seats, the rectangle portion of La Playa Stadium at Santa Barbara City College or City College. So I'm going to zoom in on the map. If you're unfamiliar with where City College is, here is City College on the map. This is La Playa Stadium. It is the stadium right next to Santa Barbara City College. And this rectangular portion is the uppermost part of the stands, the seating. And so you're looking to tell me what the elevation is right here. The next question asks you to find the S in Los Padres and the 2 in section 32. So I'm going to show you roughly where that's at. Here is to the northern part of the map, Los Padres. You're looking for this letter S that my cursor is circling to determine if it's on a ridge or in a valley. You're also going to be looking in the northwestern part of the map. Again, I'm going to zoom out. So we're always going to assume top middle is to the north and to the top left would be to the northwest. So this is the northwest part of the map. For that, it asks you to find section 32 and that northwest portion. Here's section 32. And I want you to examine here at that number 2 in section 32 if it's on a ridge or in a valley. There are a couple other features for questions 11 and 12 for students, so you're not spending so much time looking for them. I'm going to zoom back in and find the Botanic Garden for you. The Botanic Garden is right near what's called a graticule intersection. So here is the Botanic Garden. And you will use that graticule intersection to help you determine your latitude and longitude coordinates for the Botanic Garden. And then there's also just a little bit north of that, there is the Mission Canyon up here. So this is a canyon, a large scale valley, if you will. And within Mission Canyon, there's the word South Portal. So you are going to be looking for South Portal right here to determine what the township and range, the PLSS system is for the South Portal of the Santa Barbara tunnel here. So hopefully that helps you not spend too much time looking for those features. When you are determining latitude, longitude, there is a general rule or trick, and that is whichever one is in line with the horizontal part of the map in the corner. So this 34 degrees, 30 minutes, that is going to be your latitude. And whatever one is in line with the vertical portion of your map, in this case, this western edge, it would be 119 degrees, 45 minutes. Now, that does not mean that the latitude, longitude of the Botanic Garden are those values. You'll need to extrapolate other information from your margin. The degrees will not change unless you've hit 60 minutes. Once you hit 60 minutes, it becomes a new degree. And if you do not see any seconds recorded, it's because it has 0 seconds. Same if you don't see any minutes recorded, it's because it is 0 minutes. So the map makers here assumed that these were not first-time map viewers and did not record the minutes for the latitude and longitude here. Oh, excuse me, they did not record the seconds for the latitude and longitude here. So the true latitude and longitude of this exact corner is 34 degrees, 30 minutes, 0 seconds. And because Santa Barbara is north of the equator, it would be north. The longitude would be 119 degrees, 45 minutes, 0 seconds west because it is west of England. And if you said, well, if you go all the way around, it could be east. We have what's called the international dateline, which basically resets once you've gone so far east, you hit the international dateline. Now it's considered you've gone west. And likewise, if you go so far west and reach that, so on and so forth. So that should help set you up when you're looking for the public land survey system. You're going to examine, there's some township information and there's some range information denoted by these even bolder red lines here on your map. You're going to find your section and determine which township and range. You're going to determine if this is your section, that it falls in one quarter, and then within that quarter, a quarter of that. So you're essentially telling me what 1/16 of this section the south portal falls in. Okay, again, I'm gonna give a moment in case there's any questions loading. Oh, perfect. So when we write the RF for number one, will we write it as 1 to over 24,000, not including the units? That's a great question, Lisbeth. Yes, you can write it as 1 over 24,000. You can also write it as 1:24,000. It's not equal to, but we can use a colon there. And then your follow-up question, how do I determine the elevation, latitude, and longitude of the two places on the map? I'm a little confused on what numbers to look for. So for the two places on the map, I'm assuming you're referencing the same ones I had just pointed out, the Santa Barbara portal and the Botanic Gardens. So you're actually not finding the elevation for either of them. You're just telling me where they are positionally in the world. What we're going to do for the South Portal is we've identified what section it's in, and then I always think of it as it's really helpful to break it into quarters. So if this is the section that the South Portal falls in, I've broken it into approximate quarters. It's in the bottom right corner, which would mean it is in the southeast corner. So this would be north. If this is north, this is east, south, and west. This would be our southeast quarter. Then I can break up my quarter that it's in one more time, like this. And I would determine that it's in this quarter. And again, if this is pointing to the north, this is pointing to the east, this is pointing to the south and to the west, because never eat soggy waffles. Then the south portal falls in the northeast quarter of the southeast quarter of section 32 within this township and the range, which is slightly off my screen. I hope that kind of clears that up for you a little bit, Lisbeth. For the latitude and longitude, we are going to, again, look at the, we're going to look at where it falls. And the really cool thing about a graticule intersection is that it is representative of a point on the margins. So some whole or half minute generally. So it's a good reference point. So this line that I've drawn across is a horizontal line. And we're going to remember that horizontal lines mean latitude, which means ladder steps to or from the equator, either north or south of the equator. So to determine how many degrees go with this, I'm going to again reference the bottom of my map. And then not going to let me do that. So I'm going to move this here and find which one is in line here. And it's going to point to my degrees. So you'd end up with 34 degrees. And again, if I scroll back up until it intersects that point it was at, let's see if I can get it right there. It's going to record the number of minutes and the number of seconds. And then I've covered that we're north of the equator, so the latitude must be in north. And you can follow a similar process for the graticule intersection here with the longitude. And again, draw a vertical line through there and scroll down to determine that if it is vertical, it should be this degree. We have not exceeded 60 minutes. And you can confirm that by going to the east and west margins of the map, if it's going to let me scroll. I'm not sure if it will. There we go. We'll see that the degree for longitude hasn't changed. And we would record that degree and the number of minutes and seconds that it intersected right here. Hopefully that helps set you up a little bit more with that and how you can use, say, digital tools like that to guide you as you're working through the questions. I'll pop on and see. Again, feel free to add more questions as they come up, and we can chat about them if you need. So otherwise, the rest of this portion, I'm going to have you again look at that bottom part of our map down here. There's quite a bit of information and along the edges as well. There is also a map that has been attached in your work packet. This is the first time I'm showing you your work packet. And here is the map that I've referenced for you. So if we zoom in, we have a type of topographic map here, but unlike the Santa Barbara quadrangle, it doesn't tell you what the contour interval is. So you have to do some work to figure it out. And I'm going to briefly go through it for you and how we can best do that. And the best way is to actually start with our index contours. Our index contours are the bolded dark ones. And so I'm going to put a star on that one. And we'll look for the next one that falls in order. So not the same contour, but whatever the next index contour would be. So the next bolded one would be up here at 1,000. If I followed this 750 contour around here, I would find that there was 1,000 here I could have used, or 1,000 here I could have used. But I chose this one just because it's a little less busy and I think it's easier for students to see, but you could choose whichever. So to determine your index contour interval, it would be the difference between consecutive index contours, which would give us here 250 feet. Now we know that there are a certain number of contours that intersect or break up, I guess would be a better way to say it, between our two index contours here. And so we can think about this as kind of taking some steps from 750 or leapfrog, if you will, jumps to get to the next index contour. So how many jumps do we have to take to go from 750 to 1,000? We would go 1 jump, 2 jump, 3, 4, 5 jumps, and we're landing on the 1,000-foot contour. So we can take that 250 feet and we can divide it by how many jumps it took us. In this case, it was 5 jumps, and I can count the number of X's I marked there. And we find that each contour then must represent 50 feet. But I always want to double check. So if that is true, we would go 750 plus 50 would be 800, 850, 900, 950, 1,000. Turns out to be true. So that's how we can determine our contour interval if we don't have it provided to us. And there will be plenty of maps this semester where you'll need to be able to calculate that, because you won't have it provided for you, but I will assume that you know how to use those skills and how to use contours in that way. So you're going to determine some elevations of points on this map. So G here isn't on a contour, it's between contours. So we'll need to interpret if it's between, say, 900 and 950. Maybe its elevation is 925 feet because it's about halfway between the two of them. I'm looking for some answer between there that you understand between those contours. The elevation must have some barriers or bounding between those contours. But there's some wiggle room in there. Excuse me. Okay. The next ones, I will have you kind of figure out for yourself. But if you have questions, you can always follow up with me, which is drawing a line from E to B for the simplest, the easiest hiking path, and drawing a path for the most difficult path. And then we get to the constructing part. So constructing is going to sound scarier than I think it is. And there was multiple practice of how to contour in the lab, pre-lab information. There were videos and I gave you some practice ones. And so those practice ones, if you didn't do them, I recommend going and doing them. And I give solutions in the videos. So I will draw for you just a couple of contours here. And that's mostly to get you started with, make sure, okay, to get you started with drawing contours. Now, one of the things about the contouring is I've asked you for an interval. An interval is 50 feet or 10 feet. The index ones are every 50 feet, and it's always base 0, meaning you're always going to assume it's off of 0 and some multiple of 50 after that. So 0, 50, 100, 150, 200. The same would be true if we had a map area that had elevations in the thousands. If it was 1,050, that's a multiple of 50. It should have a contour that goes through that elevation point. If it doesn't, we should not be drawing a contour through it. We can interpolate, so determine how close a contour should be, but we can't draw a line through it. That would be like lying, because it's not true. It's not actually that elevation. So I'm going to start, for me personally, with the index contour, because I see that our base on our map, the lowest is 0, and the highest is 100 feet. I know that if we have an index contour interval of 50 feet, there must be at least one 50-foot contour here to allow for that 100-foot contour. I almost always start by looking at the left side of the map. You could start at the top, the right, in the corners. This is just how I do it. And if you have a different way and it's true and all of the rules of contours are valid, there's no wrong answer with that. And even still, your map is not going to look exactly like mine is, because there is some interpretation. That's where the interpolating comes in. So the index contour interval is 50 feet. I'm going to find where a 50-foot contour should be. If I start here on the left side, I know that it's going to fall somewhere between 43 and 65. So I'm going to draw here. And then again, I have 2 points. I have 58 and 40. It's going to be between them. It's going to be close to 51, but not actually 51. Again, close to 52. I have to go up here. There's a 40 and a 60, so it must go in between. Hit a creek. It must point upstream to higher elevations and then come back down. Again, I'm somewhere between these points. Turn it like this, like that, and what did I do? Nope, I don't know where it went. I'm going to draw it again really quickly, but maybe if you didn't follow along, you also could do that now and draw your own in. And I'm really exaggerating that V because you all are learning right now, and it is better to exaggerate to show me that you understand what happens when contours cross streams or not. Because this is an index contour, I need to label it. I'm going to write a 50 over here, and that's my index contour. Now I'm going to switch my color slightly, and I'm going to make it a little bit thinner. We're going to have to add in all of our regular contours, and they are every 10 feet. So every multiple of 10, just the same we would do index contours. So every 10 feet, so 10, 0, 10, 20, 30, 40, so on and so forth. So if I just did 50, I think a good place to start would be going down to 40. I'm going to quickly draw in a 40 contour. I finally get to go through a point, and then another one here, because that is actually 40 feet. I kind of missed. I know it should go through there, but I am doing this on the computer with my cursor. So let's see if I can slightly. There we go. I fudged it a little bit. Um, and so that'd be my 40. I don't have to label it. And I would do that for all of the remaining contours that are necessary to complete this map. I know I did that really quick, but I do think it is helpful sometimes to see what happens when you do have and when you don't have elevation points, because we're not connecting the dots. If the elevation is marked is not the elevation of the contour you're drawing, do not draw a line through it. That is one of the rules of contour. So that brings us to the last part of the activity, which is the topographic profile. And so when you're working through this portion, you have to first understand what a topographic profile is. I'm going to use my little rock stress ball here. Now, you're looking top down, so kind of like you would be looking like this, just like you're looking at a map or at the screen. You can see in the light here that there's some features, some expression to my rock, but you can't really get a good understanding of what the shape of it is. So we're going to imagine I'm able to cut it in half, pull it apart, and look at it from the side. Now you're able to look at it from the side, and you can see that it comes up. There's a little bit of an indent, and it comes up to a rounded peak, one little knob here, and then it dips back down. That is the profile of my hill in this case, or my rock. If I turn to the side, it'd be the same as looking at my facial profile, just the outline of my face. And so that is ultimately what you're drawing, but with data from a map. And so I'll show you a couple of points in the way that I would suggest doing that. I would suggest grabbing a straight edge like a ruler, another piece of paper, and you're going to line it up. Everywhere there is a point where an index contour crosses our line from B to B prime, we're going to imagine we can drop down a vertical line. So I'm going to show you what that would look like. You don't actually have to draw this on your lab, and I might suggest that you do at least one, and then you can erase it after. It's better to erase it so you understand, but it might be helpful for you to go back as a reference and how you got that, what you did. So I dropped down a very thin orange line, and what I'm going to do is I'm going to mark every place that along here, excuse me, not every place, the one place at which the elevation matches the index contour elevation. So here is 10,000 feet, and I got that by following this contour, this index contour, and it was labeled 10,000 feet. So I'm going to follow my orange line, and where it hits 10,000 feet, I'm going to put a mark. And so I'll continue to do this for the entirety of my line. And so this next one would be 11,000 and so on and so forth. I'm just going to put some random points on here for us for the sake of showing what a finished profile could look like. So say those are all of your points. It shouldn't look like that. But when you have all of your finished points, what you're going to do is finish your drawing by connecting these points. I know on the previous one I said, don't connect the dots. Now you're connecting the dots. And so I would connect the dots by connecting all of my stars like this. And this would tell me that this shape, as you go from here to here, of Shastina and Mount Shasta, a volcano in Northern California, would look like this from the side. So if we were there, maybe over here looking out in the distance, that might be the shape of what we see for Mount Shasta and Shastina. If this is my final shape, it shouldn't look like this in terms of where the features align. The last thing we want to do is label parts. So I'm labeling that Shasta, and maybe this would be Shastina, because that would align with those key points, those key peaks, or maybe a key valley along our diagram. That is like a beautiful finishing touch. And if you don't have the labels, but you have the profile, that's a great first step. I will ask you to label them, and you should try so that I can help direct you if say you didn't quite get it. But that's kind of the overview of my lab activity. I don't, like I said, I don't always do our activities like this with the live stream, particularly ones that I think students can use some guidance on are the ones that I do it. I have certainly exceeded the time that I thought I was going to. I apologize for doing a double today. Well, I did a double. You only got to see one. But so there may be a live stream again in a couple of weeks, probably not next week. Next week's lab activity, most students seem pretty understanding how to do it. But the advantage of joining in on these live streams and watching them all the way through is that I hide in my live stream a secret password. So if you saw last week's announcement, I actually hid an announcement secret password that allowed you to comment at the time of submission, and that that secret password would unlock, meaning I will comment on your submission with a link to the key. Now that key is for your reference and for you to maybe make some improvements. It is not to be dispersed to others. I can revoke this privilege, but I would rather students have a chance to self-learn and self-check, maybe see what kind of work I did and things like that to better their understanding. This week, your secret password at the time when you submit a comment will be Topo Topo. Topo is short for topographic map, so I'll call them a topo map. So it would be Topo Topo, Topo space Topo. And if you comment on your submission with that, it will unlock at the time of grading. I will comment with a link to access that key. So I hope that if you felt a little stuck, if you had any questions, this helped clear things up for you. Please feel free to, again, comment in the live chat. So thank you, Lisbeth, for your engagement. It helps guide towards, for me, what I can help you all with. But hopefully this helped set you up and built a little bit of confidence in how to get started. And remember, it's okay to get things wrong, to get things in a way where you are learning. I do not expect that you have complete understanding the very first go, but I do expect that you are going to attempt because, as I said earlier, It's really, really important to build those map skills because we will use them time and time again throughout the semester. So before I sign off, I will hang tight for just another minute or so in case there's any last minute questions or comments in the chat. Thank you for being here.